All right, so here we've got lesson 9-1 practice. And so let's get started. Number 10 is use the method for completing the square to make a perfect square trinomial, then factor the perfect square trinomial. So there's quite a few problems here actually, and there's not a lot of room, is there? So, I guess I'm going to try to zoom in, and we'll do it right here for each of these. Zoom in quite a bit. All right, so for completing the square, that would be x squared plus 10x. All right, and then what am I going to add here? Well, I am going to add b divided by 2, which is 5 squared. So this thing will factor to x plus 5 squared. Next up here, we are going to say x squared minus 7x, and we are going to add, let's see here, that would be negative 7 divided by 2, so b divided by 2, negative 7 divided by 2 squared. So that would factor to x minus 7 over 2 squared. And you guys can see here, this is why I prefer to write it like that, why I do the square when you're actually not going to use it, at least not on the left-hand side. All right, so that brings us to number 11. Let me zoom out here. So solve each quadratic equation by taking the square root of both sides of the equation and identify the solutions as rational, irrational, or complex conjugates. Okay. Again, there is pretty much no room here. So let me, I think what I'm going to do, hang on one second. Let me get set up over here. Off the screen, I've got all the problems as well. So what I'm going to do is I'm going to kind of move up here, and I'm going to say 11 is going to start right here. Okay, and number 11 is 9x squared minus 64 is equal to 0. So let's go ahead and isolate the x squared. So that would be x squared is equal to 64 divided by 9. All right, and so we'll take the square root of both sides. So that would be x is equal to plus or minus the square root of 64 over square root of 9, which would be 8 over 3. Okay, and these, in this case, what do they want us to say? Whether it's rational, irrational, or complex conjugates. So these are rational numbers. Rational solutions, because rational numbers can be written as a whole number divided by another whole number. And that was 11a. So let's go ahead and do 11b now. So 11b, let's see here. The problem is 5x squared minus 12 is equal to 0, as you guys can see over here. So let's go ahead and isolate the x first. So x squared is equal to 12 divided by 5. And we'll take the square root of both sides, and so we get x is equal to plus or minus the square root of 12 divided by square root of 5, which is equal to plus or minus, let's see here, square root of 12 can simplify to 2 root 3, because that 12 is 4 times 3, over square root of 5, and then I need to multiply top and bottom by square root of 5 to get that radical out of the bottom. So that is plus or minus 2 square root of 15, because that's square root of 3 times 5 over 5. And this would be irrational, because, well, it's not a complex number, there's no imaginary number in there, and it's not rational because it's not a whole number over another whole number, so it is irrational. All right, C. Let's see here. So we've got a little bit more complex. So this one is isolating the squared item here is x minus 2 squared is equal to 25 divided by 16. And I'm going to take the square root of both sides. So x minus 2 is equal to plus or minus the square root of 25, which is 5, over the square root of 16, which is 4. So that means that, actually, let me put a little arrow here. That means that x, trying to just save space, x is equal to, moving the 2 over, 2 plus or minus square root, now plus or minus 5/4. Now this can be simplified here, so let's see if I can keep this in the same space. So this would be the same thing as 2 over 1 would be 8 over, I'm sorry, you got to multiply by, oh yeah, you got to multiply by 4. So 8 over 4, it's the same thing as 2, plus or minus 5 over 4. Make that more visible there. Therefore, x is equal to, let's take the addition first. So that would be 13, 8 plus 5 is 13 divided by 4. And the subtraction would be 8 minus 5, which would be 3 over 4. And these would be rational. Rational solutions. Okay, a lot of work in a small space there. Let's go to D. D is another similar type of problem. 2 times the quantity x minus 3 squared minus 15 is equal to 0. So we'll isolate the x minus 3 squared. X minus 3 squared is equal to, and then what do they have? 15 divided by 2. So I'll take the square root of both sides. So x minus 3 is equal to plus or minus the square root of 15 over the square root of 2. And I think I'm going to rationalize this thing right away. It would be the square root of 15 over square root of 2, but then I'm going to multiply top and bottom by the square root of 2. So that would be square root of 30 divided by 2. Let's see here. Does 30, can that be simplified? It doesn't seem like it. No, it doesn't. So in this case, you will get x moving the 3 over. X is equal to 3 plus or minus the square root of 30 divided by 2. And this, it cannot be written as a whole number over another whole number, so this is irrational. These are irrational solutions. Let's see here. E. All right, yeah, so we're just going to isolate the x squared. This is a pretty easy one here. So we'll say the x squared is equal to, in this case we subtract the 49 over, divided by 4, and then square rooting both sides. X is equal to plus or minus square root of 49, negative 49 would be 7i, so 7i divided by square root of 4, which is 2. And these would be complex conjugates. Oops, that should be a J. Okay. And let's just put a square around our answer. Okay, and then finally F. Yeah, there is just no way, they really have nothing, no room for anything else, do we? I don't know how I'm supposed to fit all of these problems into this little space. It's kind of crazy. But anyway, let's do F then. And so we've got 3 times the quantity x minus 1 squared plus 10 is equal to 0. So this is actually going to yield another imaginary because we're going to have to subtract the 10. Anyway, so we will isolate the x minus 1 squared. And that is equal to negative 10 divided by 3. And we're going to square both sides, so or square root both sides, sorry. So the x minus 1 will pop out, and that's equal to plus or minus square root of 10, negative 10, which would be I times the square root of 10. And actually, I'm going to do this all at once. This would be the square root of 10 over square root of 3, and I would multiply top and bottom by the square root of 3. So that would be the square root of 30 divided by 3. All right. And this becomes x is equal to plus or minus 1. Oops, I'm sorry. Got ahead of myself. 1 plus or minus I times the square root of 30. Square root of 30 over 3. Oh, and I got to write the answer here. These are complex conjugates. All right, because there's an imaginary number in there, I. Okay, let's go to the next ones here. So number 12, we've got a ton of problems here. We got 6 full problems for completing the square. Seems excessive. Not to mention we don't have any room. So I think what I'm going to do, just to show you guys, because these are all pretty much the exact same process over and over and over again. So let me just look at my solutions, and I'm going to pick out 2 of them to do, and then I'm going to write the answers for the other ones. So hang on, bear with me 1 second here. So number 12, looks like I'm going to pick probably an easy one and then a hard one. So the easy one is going to be, let's see, do I go super easy or do I go a little bit? A is super easy. B is a little bit harder because it has fractions, so I think I'm going to do B. And let's see, C and D are just going to have your square roots, so kind of tough, but E and F have square roots and they're imaginary as well. And let's see here, E has like the square root of 19 in there, so maybe we'll do actually, you know what? No, we're going to do F because E I don't have to divide by anything. So I'm going to do B and I'm going to do F. Okay. A is, let me just write the answers for the other ones because I'm going to show B and F. So A, God, I don't even have room to write the answers in here, do I? So anyway, so A, X is equal to 6 and negative 2. Go ahead and see if I can write these answers in at least. B, I'm going to go over, so we'll do that one. C is X is equal to negative 3 plus or minus square root of 11. Always autocorrects my 3's here. E, actually let's go to D here. D is, actually I have room here, how about that, right? So D is negative 3/2 plus or minus square root of 57 divided by 6. And the answer for E is X is equal to 1/2 plus or minus, where is it? Square root of 19 over 2I. Okay, so let's go over B and F. Again, these are the exact same problems over and over and over again. And they don't give me any room to work with anyway. So B, let's go ahead and do that. So 12B. We'll do that right here. So 12B. All right, and let me scroll up on my other sheet so I can see what it actually is. All right, so number 1, first step here is going to divide everything by 2. Okay, so here I've got this A is equal to 2 and it needs to be 1. Okay, so I'll divide everything by 2. So this is x squared. And sorry, I'm looking at a bunch of different things here as I'm going. So minus 5 divided by 2x. So many problems. Every time I look over at my other screen that you guys aren't seeing, I'm trying to relocate where I left off. So minus 5 over 2x, and then minus 3/2. All right, is equal to 0. Okay, we're set up here. All right, so back to this. All right, so now I need to remove this negative 3/2, move it over to the right, and make room for a square. All right, so I'm actually going to move this over here with an arrow. So I'll say x squared minus 5/2 x plus something, put a big square here, something squared is equal to, and then this is 3/2 on the other side now. All right, so what squared? Well, negative 5/2 divided by 2. Well, this should be routine if you guys are good with your fractions, but I have a feeling most of you are probably thinking, well, what is negative 5/2 divided by 2? How do you even do that? Well, if you extend this a little bit further, negative 5/2 divided by 2. Well, what's the same thing as 2? Well, oops, not 2 over 2, 2 over 1. Negative 5 halves divided by 2 is 5 halves divided by 2 over 1. And what happens when you divide by a fraction? Well, it's the same thing as multiplying by the reciprocal. So that would be negative 5 halves times the reciprocal of 2 over 1 is 1 over 2, which is equal to negative 5 over 4. In essence, when you divide by a number, it basically gets multiplied into the denominator. So negative 5 divided by 2, no, I'm sorry, negative 5 halves divided by 2 is negative 5 fourths. All right, and down here I just showed you all the math that makes that happen. Okay, so let's go back. Again, you should technically be really good at that by now, but I have a feeling many of you probably needed to see that one again. So anyway, so this is negative 5 fourths squared. And since I added a negative 5 fourths squared on this side, I need to add a 5 fourths squared over here. And I will actually square it. So this one is negative 5 fourths squared would be 25 over 16. Okay. All right, so let's go ahead and first of all, we're going to write our perfect square down here, which is going to be x. Actually, let's move this all the way down to the other side here to give myself room, because they didn't give us any room. So this is, by factoring this should be x minus 5 halves. I'm sorry, 5 fourths. Minus 5 fourths quantity squared. All right, and that is equal to, and we need to add these together. So this 3 halves is, if I need to set this to a 16 on the denominator, I need to multiply top and bottom by 8. So that would be 24 sixteenths. So that would be 49 sixteenths is equal to 49 sixteenths. Sorry, it's auto-correcting my numbers here. 49 sixteenths. Which is kind of nice, right? Because if I take the square root of 49, that's a 7, and square root of 16 is 4. Funny how that works, right? Let me move down here. Okay. Okay, so let's go ahead and square root both sides. So I get another arrow here. X minus 5 fourths pops out. All right, and the square root of 49 would be, so this is equal to plus or minus 7 over 4, square root of 49 over square root of 15, or 16, sorry. All right, so that means that we have x is equal to, let's see here, so I have 5 fourths plus or minus 7 fourths. Okay, and taking the plus and the minus, so that means that x is equal to, let's do the plus first. So that would be 5 plus 7 is 12, divided by 4 is 3. So it's equal to 3, positive 3. And the subtraction 5 minus 7 would be negative 2 divided by 4, or negative 1/2. And there we go. There's our solutions. And let me just double check my work over here. What was that? B, and we have 3 and negative 1/2, so we are all good. Got to be super meticulous. A lot of work with fractions in there. Okay, you notice even me, I'm really slowing down, and I'm just like double checking and double checking every single step along the way. All right, what was the other one we were going to do? So that was f, which is 5 x squared plus 2x plus 3 is equal to 0. So I need to divide by 5. And so this one's going to get pretty nasty with fractions here. We got a 2/5 and a 3/5. All right, let's get started. And that was, what was that? F. So 12f. All right, so I have x squared. And let me just go up here, plus 2/5 x plus 3/5 is equal to 0. And we're going to make room for this inside here. So we'll say x squared plus 2/5 x plus something, our perfect square here. I'm going to plug in something squared. is equal to, and we're going to subtract 3/5 over here. And then we're going to add also another something, the same thing. All right, so I need to divide b by 2. So as I said before, 2/5 divided by 2 would be 2/10 or 1/5. Okay, and 1/5 squared is 1/25. So on this side, I'm actually going to do the whole thing. I added 1/25 total over here, 1/5 squared, and I'm going to add 1/25 over here as well. Okay, so let's go to the next step. So this becomes x plus 1/5 quantity squared. That's what it factors to on the left-hand side when we complete the square, is equal to, and in this case I need to multiply top and bottom by 5 to get to 25. So that would be negative 15 plus 1 is negative 14 over 25. All right, let's take the square root of both sides. So that becomes x plus 1/5 is equal to, plus or minus, the square root of, let's see here, actually let's pull out the I. Square root of negative 14 would be I times the square root of 14 divided by the square root of 25, which is 5. Okay, and this turns out to be not too bad. We're going to subtract over the 1/5, so we get x is equal to negative 1/5 plus or minus I times the square root of 14 over 5. And looks like we're correct, and that's it. So we're all good. So I guess that wasn't too bad in the end. All right, so let's go to number 13. I'm going to zoom out here. So this is the rest of the room we have to work with for 13. I think we'll be able to get it in. So number 13, it says the diagonal of a rectangular television screen measures 42 inches. And by the way, that's how they typically measure monitors. When they say you bought a 42-inch monitor or a screen or 65 inches, it's always measuring the diagonal of that screen. And then they give you typically the ratio of the length and the width. So in this case, the ratio of length to width is 16 to 9. So length, I'll just say length and width. That's the ratio. Okay. Let's see here. A, write an equation that can be used to determine the length in inches of the television screen. Okay. And then B, we're going to solve and interpret the solutions. And C, we are going to say what length and width of the television screen are they to the nearest half inch. All right. So let's go ahead and do that. So number 13. All right. Number 1, I think it's necessary to draw a picture here. So let's draw a picture. So here's our screen. Okay. And the diagonal, all right, is 42 inches. Sorry, trying to make this look decent. 42 inches. All right. Now, they don't tell us here's my length and here's my width. So we'll say length is equal to and width is equal to. They don't tell us what they are, but they do give us the ratio. All right, the length is whatever 16 times something, and the width is 9 times whatever that is. We don't know exactly what it is, but we can call it x. So the length should be 16 times some x, and the width will be 9 times the same x, 16 by 9. Okay. Now, how are we going to solve for x? Well, let's see, A is write an equation. So we'll say A, well, I'm just going to use the Pythagorean theorem, right? Here's my equation, which is the legs squared plus, add the legs squared, and it should be equal to the hypotenuse squared. So that should be 9x squared plus 16x squared is equal to 42 squared, just like that. All right. B, solve the equation and interpret the solution. So basically, we're solving for x, which is some kind of, multiplier for the length and the width. Okay. So let's go ahead and solve. So first of all, I'm actually going to square all of these things. So let's do that. So 9x squared would be 81x squared plus 16x squared. What is that? 256, I think. 16. Yeah, 256. So 256 squared. 256x squared is equal to, and you know, I'm probably going to leave this actually as 42 squared. Let's just see what happens here, because we might, you know, we're going to end up taking a square root, so that might just pop out. So we'll say 42 squared. Let's just leave it like that. You know, like I said, if I take a square root of this, then just 42 pops out. So why do it and then have to work backwards? All right, so anyway, we've got like terms here, 81x squared plus 256x squared. So that is 256 plus 81 is 337. X squared is equal to 42 squared. Save this. It's kind of slowing down on me here. Actually, let me zoom in because it might make it look a little bit better here. Oops. This is getting kind of sloppy. This is 256. Okay. So I'm going to divide by 337. So we'll say x squared is equal to 42 squared divided by 337. All right, and then I'm going to take this square root of both sides. So x is equal to square root of 42 squared is just 42, right? So first plus or minus. So 42 divided by square root of 337. Okay, and I need to rationalize this, so I need to multiply top and bottom by the square root of 337. So x is equal to 42 times the square root of 337 on the top, which cannot be simplified, by the way, divided by square root of 337 times square root of 337 is 337. Okay, so that's it. That's x is equal to plus or minus 42 times square root of 37 over 337. It's quite a bit. So it's kind of a strange number, doesn't it seem? But anyway, let's see if it works out. So let's go up to part C, which is where we're going to figure out what the length and width are. So C. So the length is equal to 16 times x, right? So let's go ahead and plug that in. By the way, subtraction doesn't work, right? Because, or the negative version of this, because you'd end up with a negative length. So we are only going to use the positive answer for this. All right, so this is equal to 16 times 42, which is 672 times the square root of 337 divided by 337, which is equal to, let's go ahead and do that real quick, 672 times the square root of 337 divided by 337 is 36 point to the nearest hundredth would be 61 inches. There's the length. Now let's do the width. And actually they do tell us to round to the nearest half inch. So hang on a second. Let's forgot that they asked us to do that. So I'll bring this down here. So length is equal to what did I just say? 36.61. So that would be 36 to the nearest half would be 36.5 inches. And the width is equal to, well, we said that's 9 times x, which is equal to, and that's 9 times 42, which is 378, times the square root of 337 divided by 337. So that means that the width is equal to, let's plug that in, 378 times the square root of 337 divided by 337. Make sure that, these are pretty hairy numbers, so make sure you plug them in correctly. So that is equal to 20.59, so 20.5 inches. Oops, hang on one second. Okay, so let me scroll out here. That's the last problem there. And save it so I can post it on our website. And let me zoom out one more. Actually, we don't have to zoom out. That looks like that is all the work right there for lesson 9-1 practice.